Yeah, so like very first thing, what I want you to do is I want to get to this GitHub repository. So I will put it in the chat. They will put it into Telegram and they will send it, and they just follow instruction how to simulate it. So get like all the necessary tools to simulate it in the test bench. So this has some setup in Linux, and that just to see how to simulate it based on tests and everything they have here. And once you are able to simulate, you can like tell me, and then you check how you can do it. And that's the next step will be to put it to the board. And we can coordinate this effort. So mostly I will probably do this after Maker Faire exhibition. But you can start to work with this CPU right now. Yeah. Then I will ask like David Harris whether I can share with you his like manuscript, and in this case by New Year we can prepare port to the boards we have. Yeah. So Kiran, so what about you? So can you do this?
Yes, Yuri, I'll try to get that done.
Yeah. So let's like all of us are trying to just clone this repository and try to simulate this test. So this is a CPU core. This is a CPU core which can run Linux. So like it has memory management unit (MMU), and it has caches. So we also need to figure out how to instantiate static memory for caches in FPGA using block memory. But initially we can probably bypass caches, so we should be able to run Linux of such a synthesized CPU and like demonstrate it. And if we do this like in January, we can get a great boost for like David Harris. Yes, and I'm actually trying to make like David Harris to speak in like other companies. Uh, uh, to like invite him to like Samsung and so on. So if he can mention like our port to FPGA boards, this like would be great. Yeah. Okay. So now several people came and we will start to debug boards. So you can actually hang around, but mostly we will now resolve problems with specific boards. Mostly pull requests. Okay. So let's close everything else. So first of all, about for those who just came, so I'm working with the Govin marketing person, and he produced some new instructions. So one instruction is instruction how to instantiate Govin how to install Govin software, so how to download and install Govin software. So this is the first instruction. Second instruction, how to put together the board. So like I was using your pictures for this thing. Yeah, so you see, you can like mention so contributed to creating Govin marketing materials, you know. So now yeah, so now like I will I will make one more iteration with the Govin marketing person, and we can all review this document, or maybe like I can give you to review it right now. So I am just like sending a link to shared Dropbox, and then you can see it in shared Dropbox. So just a second. Yeah, I put this link into chat. So if you go to chat, you can click on the first link. So you can click on the first link, and once you click on the first link, yes, Victor, and this is for you too. So like everybody, yeah. So like everybody, yeah. Now, Natalia, this is for you too. So like everybody need to like check this document. So if you click to this link, you're going to this Maker Faire marketing images, and then you go to 2024-09-18 draft 2, and here you can see three documents. So those are instructions we are writing with the going marketing person for Maker Faire. So those are instructions how to like assemble boards and how to install software and so on. So like everybody should try to follow such instructions, find like any mistakes and tell about those mistakes. So this is like first how to. So first is how to assemble board. So this is the first one. Second, uh, uh, like how to connect wires. So second, how to install. Huh?
Where is that?
This is in so like I gave you link. So this is in Dropbox. So in Dropbox, you go to 2024-09-18 draft 2. So first you go to chat, you click on the link on the first, yeah. So go to chat and click on that link, then save this link. Yeah, the only thing, please do not share this PDF to like anybody at all, because this is something I'm working with the marketing person right now, and if this file appears anywhere, this is like not finished file. So we are going to make this file public, but only like finished public version. Yeah, so this is something we are like editing right now. Yeah. So this is like strictly like inside like our like club, because this is our materials for Maker Faire. Yeah. Okay. Now you go to draft, and there are the three documents.
Zoom first.
Huh?
I do not have Zoom on this laptop, so we can Zoom.
Okay. Yeah. Let me give let me put this link. Let me put this link on a Telegram.
Where is connected? No, right now. You're not connected to the Telegraph. Telegraph. No, I'm not. Why should I connect? You know how to. I am quite sure where it's at.
Okay. Okay. In this case, what I can do.
Yes, I can get that. Okay. Then you have a link to Zoom. Yeah. And from Zoom, you need to go to Dropbox. You know.
So in Zoom, you can actually go use a web interface to Zoom. So you can actually use web interface. Yeah, this is fine. Yeah. Anyway, so like I want everybody to very carefully review this PDF file. So let me also start. get this. Okay, anyway, so next thing,
Can you copy again the Dropbox
to Zoom chat.
to the chat, please, because we just signed.
Ah, yes, okay, just a second. I think I should probably. So, does everybody have access to Telegram?
Yes, I have.
Yeah, second. Just I don't want to send it to like a wide audience, only like people who are here. So, just send me your email. I can send you link using email. Okay, so also before I close this, so here is our maker fair entry. So I put here some like additional photo pictures and some like slides with information. So now if you go to Meet the Makers, you can see our ad on this like big list of makers. Yeah, here. So Verilog Meetup here on this list. And I'm going to get some tickets and like heavily advertise it like next week and week after. Okay, first of all, did everybody get this link to this document? Let's see. Yeah, just a second.
Okay, each folder. Okay.
The folder is 2024 something draft. Yeah. Okay, so now I will copy this link to the chat again. So you just go to this chat and you can review.
It's not up. Good.
So did you get into Dropbox? Okay, great. Okay, so Natalia, so thing number one, I want you to use instruction to like add microphone and sound output to this breadboard. Yeah. So you just go to Dropbox and you look to the instruction. Yeah, but this is actually a short instruction, and there is a longer. Oh, yeah, this one long instruction here. So first thing, what I want you to do, I want you to connect the microphone and like everything, and use your setup to put everything together and start graphics, sound, and so on. Yeah, to just assemble everything. So this is thing number one.
That is the key.
Okay, so is it working?
This is not. All right.
Not working. What about this one?
Working. This I only just make project. Yeah. But
So yeah, this might not be. Yeah, this you need to debug. By the way, with the P mode, it's much easier to debug because this one is finicky. This one is not finicky. Okay.
So it can be.
Oh no. I don't want you to do. I mean, like, you can do it from scratch, but then I have to review everything from scratch because we have already two projects. This is fine. We can have alternative of configuration, but I also want you to add. Huh?
I just want to make this project work.
Yeah. Yeah. So this is the very first thing we are going to review. Yeah. So let's start reviewing maybe your board first, then your board second.
Which file are is fortunate?
So there are three files.
Yep.
So I want you to review all three. I want you to carefully read all three files, review them, try to find mistakes there, make like any recommendations. Hi. Yeah, so make any like recommendations. I want you to carefully read those files, but please don't share it to like anybody because we are in process of editing with the going marketing person. This is something we want to finalize next week. So now I want different people to review, find here errors, and use this file to like assemble and start running everything.
For the assembly, the synthesis and configuration.
Huh?
For the how to
Just read all three files. Don't ask me. I want to test this document on you. So imagine you're a person who came to Maker Faire, pick those three pieces of paper and have no idea about anything. Yeah. Okay. Now, in addition to it, I want you to give you to assemble some stuff from here. Yeah, so basically I want both of you to assemble everything using this instruction. And yes, so both George, Natalia, very first thing you're getting instruction and you assemble complete demo. Okay? Yeah, so now George, I want you to build a set using components you can see here and completely assemble the whole set. So I want at the end of the day to have two completely assembled sets here. You use those sets in October in Maker Faire, okay? Yeah. Okay, so this is some like work for you. If you need any more components, you can get here. So you can get components here and here. So here you can search for components you need, or maybe get something from here. So yes, George and Natalia, like look here, yeah, Natalia. So if you need anything, here is all the components. So just like search what you need in here. But first try to search here because here they're like mixed components and here they're all arranged. So you have all necessary components here and they want you to create a full complete setup. And I can give you one of those boxes. So you should have two boxes that include everything. Okay, by the end of the day. Yeah, everything from scratch. Yeah. So just get all components from here. Yeah, okay. Good. Okay, now I will work with three of you to debug the boards we have. So okay, so Victor, did you just modify file for this thing or wrote everything from scratch? Yeah, okay, so you just modify. So let's start from this one. So you're saying that yeah, and let's maybe correct what we so let's maybe correct some problems we have here. Okay, so wait, Timothy, so you were working on
20K.
On 20K, yeah, okay, good. So and okay, so Yuri, you were working on this one. Okay,
Yeah.
okay, so now let's start. So is 20K working now or what?
That's a good question. So things that I verified that work just fine. OD out works.
Ah, it's working.
TM69 works.
Uh-huh.
FPG buttons, LEDs, everything is fine. HDMI works, no issues.
Okay, good.
I was not able to make microphone working.
Okay.
And LCD is not.
Yes, I think yeah. Okay, so let's see different issues because I didn't review 20K board yet, so we will review it now. Yeah. So let's get the easiest board. So let's start with the A-Links. So A-Links board is very important because A-Links is used in Azerbaijan, and they have tons of them. Yeah. So now let me start with the Victor and the A-Links board.
Quick question. Do you know what power or this one? Which one?
You need to read it.
Read it.
So this one,
Power.
this one is saying power, and this one is saying UART.
Yeah, probably yours.
So
I guess.
yes, the things that you need to insert it here. Okay. Okay. So okay. So let's start from reviewing pull requests. Okay. Requests. 7 pull requests. Okay. Okay, so Victor, where's your pull request? Ah, okay. So can you make pull request so we can review it?
I can.
Huh?
No, I know. Like, I mean, not like.
This is fine. This one just make like temporary pull request. You see what is not finalized because I don't expect a lot of changes on this board. But let's finalize it together. So let's finalize A-Links because A-Links we definitely need have to finish today. Okay, so while you're doing this, okay, so now let's see to refactoring this board because we also need to finish it today. The files changed. Wait a second, why did he remove this thing? Ah, okay, this is fine. So key N. So he puts this back, key N, which is good. Yeah, you can put this thing back. So just create some sketch document. Uh, don't need corpus. Okay, so let's see refactoring. Okay, this we are going to put there. Okay, so here he put notes that the key of polarity is negative, and the switch is the same, LED is the same, and he put back this thing in digit N, GPIO. So this is what Alexander was doing, and he put GPIO J7 and then GPIO P1. Okay, so this is fine. So then he added with GPIO, which is fine. And then he added so clocks. Okay, UART. Okay, so far so good. Added VSync, RGB, lab key. Okay. Then he added VSync. Okay. HSync, VSync. Okay. Okay, this is good. Okay. So actually, what like everything he did looks good. So we just accept this merge, and so so Yuri should be able to assemble. So now you are making our final demo.
Okay.
And this demo will be used by like in two places. First, we may use it during Maker Faire, and then I have actually one teacher who is teaching children, like school children. He wants to use this board for teaching children FPGA. For this reason, we need to have a perfectly well documented demo and make a photo picture for the connections.
Okay.
So let's do it.
Alexander, right? Another.
Yes.
So I need to pull his changes.
No. I will merge his changes now, and then you just do git pull and you are done.
Okay.
So what I do is I do.
Yeah. The question is, last time I checked and it's the current state. So basically, it does not work in graphics branch. It does work in main branch.
Yes, I know. So we are making it working in new graphics branch.
Oh, okay.
So just a second. This is our goal. Yeah, this is our goal. Just a second. Let me stop. Oh, wait. I did something wrong. Refactor. Merge pull request. You're ready to review. Yeah. So merge pull request to new graphics. It's a new graphics branch.
Oh, okay.
To new graphics branch. So confirm merge. Okay. So this is merge. So let's see. 1 second. So now we are doing git page. You are doing git diff. Okay, so he is something else. Okay, you're doing git pull. Okay, so now what I want to do, I want to compare it with the main. Well, that's first. Hi. Okay, so yes, Yuri, did you come here first time?
Yeah. I'm new to hardware.
Okay.
I just need to see what was going on.
Okay, so but what are you doing? So what is let me get what and let's chat with you a little bit. So you can just try to like assemble it right now and we discuss it. Yeah. So just do everything. Just do like everything based on the thing. Yeah. Okay. So what is your background? So what are you doing?
Software development, but like high level. So Golang.
But with what kind of software?
Golang, programming language. web applications in Go.
Web. Well, Golang with a web
Yeah.
application.
And some front end as well, React.
So
I mean, I
front
have-
end and React. Okay.
I have some knowledge of reduced instruction set programming,
Mhm.
like assembly language programming.
Like I said,
Over many years.
but did you use like RISC-V, MIP, Spark, ARM? So which one?
We used a PIC 16F84 chip.
PIC microcontroller.
Yeah.
So which one exactly?
PIC, is that PIC 16F84?
PIC 16. Okay, yeah.
Yeah.
Okay, okay. Mhm.
So
So you know assembly of PIC 16 to some degree.
yeah, I'll be able to recall it.
So you have some basic idea about like assemblers, but yeah, this okay.
Like registers and like assembly language programming. Yeah.
Okay. So now, okay. So and what are you trying to like achieve with like Verilog and hardware and so on?
Just to have just to like refresh and develop my understanding really. So just to
Okay.
learn like
Yeah. So, but did you but have you ever worked with hardware description languages like Verilog or VHDL?
say that again, sorry?
So, have you ever worked with hardware description languages like Verilog or VHDL?
Is that lower level than assembly?
Yeah, this is like different. Let me show you a couple of slides for basic introduction. And then like what I will do, I will ask you to help those gentlemen to create some setup on FPGA board, which actually does not require any knowledge, just you follow instruction how to like assemble these pins, then you assembly set for yourself, and then you can work on that set.
Like so,
Yeah.
I'm not exactly sure what FPGA is.
But this is what we will explain in just a moment. So I have a presentation for it.
Or just from like basic work on like
Yeah, I will show you some very basic idea what this thing is. Yeah. Because I have special presentation just for this like purposes, like introducing you to hardware design in 15 minutes. So basically, okay. So those are like acronyms. So hardware description language is language used to design circuits, and register transfer level is like our level of abstraction. So like so this is and application specific integrated circuit is like pretty much any chip you have right now, like chip in the phone or microcontroller and so on. And a system on chip and our field programmable gate array. So we are using methodology which is called RTL to GDS2 methodology, which is the way how chips designed from like early 90s. So for the last like 30 years. So before people were using just mouse drawing some schematics on the board to make chips, but now people design using language called Verilog. And essentially, we are using this language. So like any chips we see, like CPUs, GPUs, everything designed in this way. Now, okay, so here's the difference. So here is like some like microcontroller. Let's get your PIC 16. Yeah, a good example. So it has inside CPU core and it has memory. And the CPU core is a digital circuit which essentially what it does, it gets a stream of instructions from memory and changes its internal state. And this is what execution is. So just getting instruction, changing register, sending transactions to the output bus. So and the CPU core is written in Verilog.
Right. Yeah.
And in memory we have a software. So now, yeah, and things like peripherals also written in the Verilog. So if you have software, so you have like C program, and C program becomes like assembly and becomes a bunch of machine code, right? But Verilog is something different. In Verilog, you write code, and this code becomes hardware itself.
Right.
So it becomes like transistors, wires, and so on. So basically, this module means that you have input wire, which is clock, and you have input wire, which is reset, and you have like output wires, which are 2-bit connected to like a counter, so you like output. And what it's saying is that always, every time clock goes from 0 to 1, if you have 1 on reset wire, it sets this 2 bits to 0, and otherwise it adds 1. So like every time you're doing action on like positive edge of clock. So now basic idea of digital hardware is that you have essentially combinational cloud, which is just a bunch of like AND or NOT gates, and you have storage elements, which is a state registers. So those registers are not like registers in assembly language. In assembly language, your registers are only visible to software engineer registers. But this is a generalized register. It's a D flip-flop, and they can store like any state.
So does it serve the same purpose?
Huh?
Does it serve the same purpose as the traditional register?
Actually, assembly register underneath is also same. It also uses D flip-flop. Just they're visible by software engineer, but most of registers in CPU are not visible by software engineer. They use for like internal purposes.
So sorry, these registers are the ones that are not accessible to the programmer. Is that right?
Yeah. But registers accessible to programmers are also implemented this way.
That way.
Yeah. So basically in hardware design you have two things. You have combinational logic and you have sequential logic. And combinational logic just means that you write module like inputs and outputs, and you put something to the inputs, and then you have like OR, XOR, and you wait for several like picoseconds, and you have output. But now the question is, how much to wait? How can you be away? How can you be sure that you have like valid data, like an output? And for this reason, we're using another signal called clock. And this signal clock just like tells that during this clock period, you have enough time to finish all the changes and to record this into storage element. Yeah, and then you can implement like state machines, and so this is like the simplest example, of what a hardware does. And actually, any like CPU or like anything else. Yeah, let me actually share this screen. So like anything you have in hardware, from like the most complicated like multi-core GPU, CPU and GPU clusters, like everything can be reduced to this scheme. You have combinational logic like adder, and you have storage elements in D flip-flops. And essentially, hardware is specifying how your old state becomes new state. Yeah, and so here's like manufacturer. Okay, now what is the FPGA? So when you create hardware using Verilog, you need to make a physical chip. But to do physical chip, you need to make order for a foundry, and this takes like many months, and then you get chip back. Now the question is that how can you debug your design before it comes from fab? So you can do this using simulator, or you can use a special chip called FPGA, field programmable gate array. And this chip is essentially a matrix of elements, and you can use configuration memory to say that this element is like AND gate, and this element is OR gate, and this element is one bit of memory. And this is the whole like matrix. This is like Lego set. So you're like building from like Lego set. And this is
from the HDL.
Yes, yes, exactly. You got it right. So you can compile either to fixed chip, or you can compile it to field programmable gate array. And they're using somewhat different software, but essentially with the field programmable gate array, like implementing circuits with FPGA is like implementing programs in like Python versus implementing programs in C. So like in like ASIC, you like implement in C. So this runs fast, but in Python, it has bunch of like a lot of overhead. Because to make this reprogrammable, to make it changeable hardware, you need to implement construct called lookup table. So like instead of simply make like AND gate, you make a structure with so-called multiplexer. So multiplexer is a hardware if. And you just make a constants like A, B, C, D. And basically now this whole thing acts if you put like ABCD 0001, the whole thing acts as like AND gate for X0 and then 1 provision U Y.
Right.
You see? So you can essentially use memory to say that this piece of hardware behaves as AND, this piece of hardware behaves as OR, and this piece of hardware behaves as a 1 bit of memory. Yeah, so now so now there's some literature and stuff. So now basically what we do here, we create some like examples used by like teachers for like electrical engineering labs and labs based on Verilog hardware description language. So they can first like experiment with FPGA boards, and once design is stable, they can make order for a fab and have ASIC. But most of people don't go this road and just work with FPGAs. Yeah. Also, FPGAs are used not only for like education, but FPGAs are used for prototyping. Like any large electronic company like Intel, Apple, Samsung, they have like some like a multi-million box full with FPGA is like a ZIBU emulator where they put their hardware design before it goes to foundry. And then they can debug. So it's certainly slow. It requires like tons of stuff, but it's better than to do this using simulation, because simulation you can simulate it with like a kilohertz kind of frequency, but with emulator you already have like megahertz. So you are getting like a 2 gigahertz chip you run with FPGA on like 50 megahertz. But with simulation, it will be just like a kilohertz. So you're using FPGAs to prototype ASIC, but you can also use FPGA for parallel processing of like video data, for instance, because it has a lot of parallelism. You process like a lot of data in parallel, like unlike CPU, which just gets instruction after instruction. So like FPGA are also used for like audio video processing if you need to do this fast. Yeah. So now with such introduction, what I want you to do.
One question.
Yeah.
You mentioned like there was the analogy of like Python and C.
Yeah.
Just remind me, what are the
So like it has like ASIC is C and FPGA is the Python, but here you start from the same language, which is Verilog, and then this Verilog goes either to FPGA or goes to ASIC. So like design is the same, language is the same, but you can implement it either in a slow way today, right now, on your table, or you can implement it fast and low power, but you need to send it to the fab to create a chip.
And that's ASIC.
Yeah, this is ASIC. Yeah. So what we do today is that today I want you to assemble such board for yourself. So I have a bunch of such components using instruction, which right now I'm writing together with a marketing person in Govin, which helps us with this club. And essentially what you do is that you get this board called Tang Nano 9K, which has a FPGA chip on it, and then you connect it with the like LCD screen and with some like buttons and 7-segment display, and then you connect microphone and sound output, and then like implement bunch of examples of what you can do in hardware. So this is all like you can process music, graphics, all in hardware without CPU, without assembly, everything in straight hardware. Yeah, so basically as a first exercise, so because we are going to show this on Maker Faire to like introduce people to hardware, I want to use this to test on you.
Yeah.
So now I will give you instructions. So here is the instructions. Oh, by the way, what kind of computer you have?
It's an M1 chip.
Yeah, so unfortunately, this synthesis does not work on Upper Macintosh. Actually, it works, but with some heavy tricks. So, like, do you have like any like x86 Linux or Windows or something?
No, I've only got 2 Macs.
2 Macs, yeah.
Might be my older Mac is not an M1.
Yeah, but even with all the Mac, you may try to plug bootable Linux, but yeah, I can actually loan you maybe next time. I have like many small old computers, so like I can loan you for this purpose. But right now, let's just assemble board. Yeah. So first you you can just like read from point of view of person who see it first time.
Yeah.
You read all these instructions. You just, if you notice some like typo or something, you tell me, because this is something we wrote just 2 days ago.
Okay.
Yeah, and we are like editing. Then you together with those gentlemen, what you do is that you go here. You search here parts.
I get the first step. We
Yeah.
were discussing this. The first step is to get the board before getting into all the software and things like that.
Yeah. So you need to connect everything on board and make sure it's working. So I want you to get components from here, like you get like breadboard from so you get like long breadboard from here. For example, this one. Or you find another like long breadboard. So you get all the components from here and you assemble, and then when you create the whole thing, you put it in separate box and use it as a demo during the exhibition. But here is a different component, so you just look to the instructions and you find component you need from here.
Okay.
And it looks like I need to put more. Yeah, but first you search here. Just make sure not to mix this and this one, because the here they're all in groups. All the like extra components. And here some of them are half assembled and some of them are not assembled. So here is more like spare parts, but here is for. Yeah. So wait a second. I thought that I have more. Straight words. Yeah, you can also use one of those PCs to so this one Windows, but I also have Linux bootable drive. So do you prefer Windows or Linux?
Linux is fine, yeah.
So yeah. So what you can do is that you get such computer. So you work with them and they will show you how to do this. So then you are using bootable SSD drive. Second, let me get bootable SSD drive. Yeah, so you get bootable SSD drive. This is master, so I want to get from here bootable SSD drive. So you're getting bootable SSD drive and you boot Linux from this drive.
Well, if Windows is on there, I can use that. That's fine.
It doesn't really matter. Just need to find. Yeah, here. So you can boot from here. So you can just insert it. Yeah, let me show you this case. Give you different laptop, because with this one you need to go into. Let me use them to instruct you how to boot it.
Do you accept a suggestion? I will go first to build the board.
Yeah, so first you three of you build the board. First you build one board, try different examples.
And then with the board running, we get into the software.
Then you can go to this one. Okay, so let's start. So three of you build the board. You can build 3 boards at the same time. So let's get all 4 boards. Yeah, let's build together 4 boards, because we need a bunch of boards for Maker Faire, and let's build all of them. So get all boards from here.
The list of materials, that's a good one. Let's take it.
Which one?
Yeah.
Oh, unfortunately, I forgot some breadboards at home, so you may need to. But you can use 2 small breadboards and combine together into one large breadboard. But if you use 2 small breadboards, you also need to put connector between them. Unfortunately. Yeah, so I want you to build 3 sets, but let's start from first set. Let's start from one set. Set 1. Let's build 2 sets, and after this we'll see. So this is another. So you have that breadboard. There is another breadboard, and okay, this one is empty. Had to bring more. So you just find components here. Just find components here, and I want you to assemble the whole set. Yeah. So just you find components. Let's not search it here, because here it's more like chaos. So you got bootable CSD. Okay. So now we need to connect everything here to graphics.
I
Just send pull request. Okay. So now, so with you just look to QSF file.
Changes here. I'm trying to check if basic log work.
Okay, so now we also need to finalize this board today as well. Yeah.
Microphone didn't work for me.
Huh?
Microphone did not work for me.
Okay, yeah, we'll check microphone. Okay.
LCD display also didn't work.
Okay, but let's assemble something which works. So let's get HDMI. So let me just see, and then we can debug everything else.
Where is the FPGA board?
Huh?
Where is the FPGA board? Here.
Yeah, just search it here. Here. So just get bored. Okay. Hi. Yeah. Okay. Yeah. I'm actually going through wrapper, so you can actually see how wrapper is organized. Okay, so let's start with this board. Yes, MUCC. Yeah. So this one is Altera board, but Xilinx board wrappers are organized in a similar way. Okay, now also let's see to A-Links board. Files changed to one. Just three. Okay, let me get water. Where's my water? Wait a second, is it yours? Or mine? Okay, this is mine. Huh?
So, for 10 nano, you have only LCD 800 by 480, and we do not have LCD 480 by 272. I think that's why this LCD didn't work.
I can give you 800 for 480.
Not, don't use this box.
No, don't use this box is something else. So use only what is here. Yeah, so I will close this because I don't want to mix them. They all. Wait a second. Is it from here? Yeah.
The point is, I went simply for the display.
This, okay, yeah.
Where are the displays? Here. What's the table?
If there are no displays here, I will give you another. Unfortunately, I forgot to put some extra stuff from there.
Okay, we need the
I will give you just a moment. Here.
that's one.
Is the one
And we need
display?
the 7-segment display too.
It should be there.
No, we don't have here.
Definitely should be there. But don't see here. Wait a second. Okay. Wires. Sound output FPGA. Oh, here is a bunch of displays.
Oh,
So this is the second display. We have two
We're
displays.
just building one.
yeah.
Between three of us, we can build one.
Yeah, but then we need to build second. Yeah. Oh, there are no.
No, 7.
Oh, so sorry. Yeah, just a second. I will get from another box in this case.
Got the displays. That's cool.
Okay, so let's find it here. This case, yeah. Yeah. This box was misplaced. Yeah. So here.
Yeah, I already coached you.
Here.
Yeah. Display.
We need to put this one here.
So I've got ones and twos, which I got one of them.
Okay. Just a second. So let me find the display for you.
You need one more breadboard.
Wait. I thought we had that breadboard, no?
Here.
Ah, okay.
Yeah.
Yeah. Okay. Here I have a complete set. So let me give you breadboard from here. Yeah.
Okay.
Here is available.
That.
Okay, so speaking of wrappers, so let me show you how wrapper looks like, and let's get like another Xilinx board.
How are you supposed to? How are you supposed to?
Huh?
That's part of the thing we need to work.
Yeah, yeah. Like, because we don't know what that looks like. So it'd be good if like.
Yeah,
the
this
numbers-
is how you, so
So
you're
the
saying
num-
that
the-
number should be
Yeah.
put here. Yeah. You can write a note here that need to show number, yeah. So what are you looking?
And the soundboard,
Yeah. Soundboard supposed to be.
yeah, I saw it here.
Okay, so here is sound output, but not the board. Okay, let me see maybe it's here.
It was the displays.
Ah,
Very important. Oh no, this is the
no,
potential.
this, okay,
Yep.
yeah, this is the soundboard, okay. Okay, so here is a Xilinx board, so let me show you how wrapper looks like. So, okay. Yes, Timothy, I can actually show you some information about Xilinx wrappers as well. So I will show you overview. So how like everything is organized. So basically we set a goal, run the same Verilog code on 50 different boards. So how we are doing this? We have if you go to a repository, there is a board directory here with the different boards. So essentially, to create wrapper for your board, you need to create another sub directory here. Then you are going. Yeah, let me put to branch new graphics, because this is the current branch. Now, we got this Nexus A7 board, and here there are 3 files. So one file is a board specific tickle, which just it's a file used in our scripts internally, where we set only 3 variables. One is FPGA board and part name and hardware device, and you can find it from vendor examples. So, or you can find it from GUI, because GUI also lists it when GUI is trying to synthesize. This is one thing. Second, you second you need to find XDC file from the vendor, which is the digital. So to find this XDC, so you probably have this XDC file here already. Okay. So basically you need to write only one file called board specific top.sv. And this board specific top, what it does, it has some glue code, and then it instantiates some module called laptop. And this laptop is actually user module, which is common for all different FPGA boards. So basically, goal of this .sv file is to map specific board to some like abstract board. And this abstract board is defined using parameters with like a number of keys, width of key signal, width of switch signal, width of LED signal, width of digits on a 7-segment display GPIO, then screen width, screen height, and size of color channels. So how this like wrapper looks like? So let's review. First we put a parameters for each board, like this board is a 100 megahertz clock, but pixel megahertz, which means that frequency of a VGA monitor connected to this board. So on some boards we are using VGA, and on some other boards we are using HDMI, and on other boards we are using LCD. So different things. Then we have like width of key, signal, switch, LED, number of 7-segment digits, which is 8, and GPIO. So GPIO is all the pins here. Now, if your board does not have a 7-segment display or doesn't have a insufficient number of keys, we have a special board called TM1638, which is connected to the board. So you can see this special boards, for example, here. So like I believe that for your board, you may need to connect the thing externally using GPIO. Yeah. Now, so what we do next is that we are listing those pins which coming from the vendor. So basically we are mapping vendor pins into our abstract pins. Now, we just for convenience make a lowercase clock and reset. Then we set zeros to pins we don't use, like avoid warnings. Then we instantiate X and Y for VGA coordinate, because we pass to the abstract module output from our VGA controller, which is instantiated inside. Then we also instantiate module for slow clock, which is 1 Hertz clock. This clock is used for some demos. When we demo like CPU, what happens like every clock cycle, we put clock with the frequency of 1 Hertz clock. Then we have this module we instantiate abstract board, and we pass our buttons from this board. We pass switches, we pass LED, and then we get from there VGA signals for red, green, and blue, and the microphone and sound. And then we instantiate VGA controller here, which generates signal H-sync and V-sync. And then we put a module for microphone and module for sound output. That's it. So now let's test this board, how it works, so that I can put this board into tested. And then I will show you how board with TM1638 looks like, because your board doesn't require it. So your board has the same PMOD connectors, so you can put everything to PMOD connectors. In fact, we can implement it like right away today, because like implementing this on your board is like a half-an-hour operation. So now, while we are talking, let's just go to terminal. So yeah, so let's get the graphics. Yeah, so we have here like a bunch of scripts. So we need to run script called choose FPGA board 06. Choose another FPGA board, and we have a menu, and in this menu we put this is Nexus A7, so 24. Okay, and after this we are running script called synthesize, and it starts to synthesize for this board. That's it. So now, in order to add your board, you, in addition to those 3 files, you need to modify one more file. And this one more file is the script, the bash script, which is located here. So you need to put your board to this case statement to just tell to the script that you're using Xilinx FPGA toolchain. Yeah. That's it. Okay, so let's see where else we have this. Grep, Nexus. Yeah, we have it only in one place. So you just need to put your board name in this list. So that's it. Now, while it's synthesizing different terminals, it's synthesizing here. So because your board requires adding TM1638, you so this is how it's connected to like RT board. So you can use this like as an example. So what we do here is that we instantiate. Oh, by the way, this has to be changed. I have to change it. So what you do here, you instantiate special module called TM1638 board controller, and then you put certain signals to GPIO pins. These GPIO pins are your P mode, and then it gives you your digits, your like access to digits, LED, and keys, and you use digits, LED, and keys from that Twitter board. So, so what you do is you get this thing, then you get male to female connectors. So for your purpose, I think it's better to get long connectors rather than short, because you want to put it long from a board. So you get connectors. So you need like how many of them? You need 5 of them. Okay, let's state this. Yeah. So you get from here five connectors, and let's make sure that you have red and black for power, and so let's put red and black separate to make sure that we don't confuse them. So you just connect here ground to black.
Right on the edge.
Just make sure that you don't do shortcut. And here, and then just connect for strobe clock data, just for the sake of like yeah. So we just get like this three. Oh, sorry. So we just get the 3 wires. I usually put data on green. So let's just connect it here. Oh, sorry. So as a very first step, you just connect your board with TM1638. Oh, by the way, does your board require commercial license, or it can live with educational license?
I don't have anything.
It looks like it may need commercial license. But anyway,
I'm using just regular.
but using Vivado commercial or educational, did you put less? Free. Yeah. If it's free, that's fine. If it's free, this means that it's fine with. Wait a second. This is green. I put in strobe. Doesn't matter. So what you do is that you need to put these wires into. Oh, wait. Yeah. Sure. So I should do this right away. So you connect this way. Yeah. So what you do is that you just put this 5 wires in your P mode, and you implement that wrapper. Then it should start to work right away. Yeah. Right here. Okay. So you got this, and then you connect like others. We can connect VGA display through P mode as well. Now. Yeah, so what you do is that you probably start from, so let's see what board to start from. Okay, this one. Okay, so here VG is connected to, okay, well, this is actually obsolete wrapper. So what you can do, you can get from a Zybo board. Zybo is well implemented. Zybo, yeah, so Zybo board has everything. Oh, but this UART, we may need to implement different way. Okay, so what is the clock frequency on your board? Is it 100 or?
It has, yeah, it can do 100. It's got a, yeah.
Okay, yeah, so you can, okay, yeah, but here I think it's a little bit too much complicated. Okay, so which board to get for you? So you can use Nexus for Nexus A7 as a base. So Nexus, because it's the most like plain standard board, and then you can get TM 1638 from RTA7 board. Yeah, and that's it. Yeah, so just like clone this repository from branch called new graphics, and so first you create your own fork in the GitHub. So do you have a GitHub account?
I have it on there, yeah.
Yeah, okay. So first you go there and do fork. So let's actually do this together. Huh?
One question. For putting the power,
Yeah.
there is no cables and a red and couple of red and black for power. We
Red and black.
yeah.
So yeah, actually color doesn't matter, but it's better to put red and black correctly. So just get other. You don't need to put two as I said, just use single black and single red. Yeah.
Okay.
So next one thing what I would, yeah, this is the ground. Wait, did you put black into? No, this one.
Oh no.
This one is red. It's a VCC. You need to put VCC. Okay, so let's go to GitHub. Yes, Pete, I will review this thing with you later. So let's create wrapper for this board. So just go to GitHub.
I can keep you.
Okay, now in GitHub you need to search. But this is GitHub GUI. This is not web, right?
This is, yeah, this is desktop.
Yeah, let's not use desktop because I don't know how to use it. Let's go to web based. So let's go to the web wrapper.
Yeah.
So go to GitHub. Okay. Now let's search on GitHub Yuri Pancho. So my name. So YURI space Pancho PANCHUL. Yeah. Okay. Okay. Just a second. What? Why doesn't it find okay, so first you need to sign in. And yeah, so sign in first. Okay. So second step, so you are finding my repository. I doesn't want to go to my name. Second. Yeah. So you're going basics graphic music. Then you're doing here fork. And then you do here that create a new fork. Yeah, so this is your account. So you can create with the same name. Now it's important not to copy. It's like uncheck this thing. So you copy all branches. Okay, so now you do create fork. Done. So second thing, you go to code and you copy and you just clone this repository locally. So you can do it with your desktop. It's like up to you. Yeah, but now.
That's what I've been doing normally.
No. So in this case, you should do something else. So what you can do is that. Let's actually close Vivado. You probably don't need it. So first of all, let's make sure that everything works with that board. So let's close everything here. So you can work either with terminal or you can use inside VS Code. It's up to you. So which editor do you usually use?
I've just been using this notebook now.
No. This is fine.
BI or something like this.
Yeah. Yeah. So basically here you need to just create location where you want to have projects. So you can go to like C, like GitHub or something, or just put. Yeah. So just to go to C, create a directory called GitHub. Yeah. Just like mkdir GitHub. Okay, now go inside here, so cd GitHub. And then do git space clone space, and then Control V, just get this whole thing, just do Control V. Yeah, Control V. Yeah, enter. Opa. Okay. So, okay, now the problem is that you. So do you have Git for Windows installed or not?
I don't know. Maybe not.
Okay, let's see. So, but in this case, how do you use? So you may have Git installed, but maybe this Git. Yeah. So you have GitHub desktop, but you don't. Okay, let's see. Yeah, you can try Git for Windows. Oh, but GitHub may not include Bash, and you do need Bash as a scripting
I tried
language.
Git Bash earlier today.
So Git Bash, you don't have a Git Bash anyway, right? So let's see. How to search here? Where's the search? Second. So you don't have Git Bash. Okay. What you can do is that you can simply install Git itself. I don't think it will conflict with. So this is for Windows. So this one. So you can just get it installed. But when you install, there is one check what I want you to do. This actually allow you to easily install without putting Git into pass, or you can put into pass Git only, or you can put Git and Unix utilities like find and sort. But if you do third option, it will overwrite Windows find and Windows sort. So are you okay with this or not?
Can overwrite what?
It will overwrite commands find.exe. So if you do find, this is Windows find, or if you do sort, this is Windows sort. But if you check that option, it will put its own Unix Linux sort. So that's fine. Okay. So that one is better because it's kind of more reliable for the scripts. Also, it should work even without checking that option. So now once it finish, you can just run. Let's just run installer. Okay, so like yes, I want you to connect all this. Yeah. Okay. I will check it. So let me finish with him. Yeah. Now, like, if you don't have anything to do,
No, I don't need to do. Okay, this I make project, but it's still not working. I need to debug it. It looks like working.
yeah, but in this case, get another board and create a P mod. P mod, I know that it works for sure. This one, it requires debug.
No microphone, no this.
Nothing.
Nothing. Yeah. So this is like,
So what if you disconnect
so
everything?
is it 5 volt?
No. Do not try to mess with the 5 volt. The 5 volt will burn FPGA. Use it only 3 volt.
I
Yes.
read that it would work.
Yes. I know that it says 5 volt. Do not use 5 volt.
I cannot use 5 volt. It's passive.
Huh?
No, it's passive. It doesn't. Yes.
No, with this thing you need to use 3 volt. It says 5 volt. Do not use 5 volt. Use only 3 volt.
No, okay, I will.
Because 5 volt you may burn FPGA. Okay, so if the thing does not work when you connect, there might be a problem with the FPGA itself. But I remember that if you remove everything,
No, it's a blinking. Like
so like it does blink.
it's by default program.
Okay.
Okay.
So if you insert it here, so can you actually assemble second board with a P mod? Yeah.
Okay.
So just look okay.
Certain like up here.
Okay, so let's see option. So this option you can just leave as default. Okay, so open git bash, git associate. Okay, you can think you can use it as default. Site. Yeah, this one. So git from command line and from third party. So I prefer putting this one. So if you are fine with putting this one, yeah, everything else can be left as default. Yeah, check out Windows style, commit Unix style, fine. Fast forward the merge, fine. That's all. So the only option we made custom is use Unix find insert. Everything else is default. Okay. Yeah. All physicists and engineers use.
I a long time ago. I guess this morning I was trying to install the Linux that
Okay, this is fine. Okay, so now to finish. Okay, so now okay, let's close this thing. Okay, so now but it does not put it into pass immediately, so you need to also close and open this again. So okay, what is this? Oh, do you want application? Yes, I do. Okay, next. Oh, wait a second. It does it again because it was asking. Do you want to change to your device? Ah, this is fine. It will just reinstall it.
that's my
Oh yeah. Is that my photo?
Yeah.
No,
Okay, so now let's get back to terminal. Or if you yeah. You're just running batch file. So terminal. So with command terminal. Yeah. So just run the terminal. Yeah. So just go to the place. To GitHub. Okay. Yeah. Okay. Now. Yeah. So now git clone, does it memorize it? No, it doesn't. Okay. So now git clone. Okay. To remove big files from here because it's very slow. But anyway, let it run. One thing what makes it a little bit convenient is to install VS Code. So do you want to install VS Code while we are doing it?
Sure.
It's a Microsoft VS Code. It just makes it because it's like a plain vanilla code editor. So VS Code just I like to use it because it's kind of easy for many users. So you can use Visual Studio Code. Download it for Windows 11 user installer. This very slow. Anyway, let's install it just for the convenience. Okay, so let's just wait. Now what we are going to do is, before we do this, let me check that board works with graphics properly. So something I wanted to check today. Oh, okay. So this is working here, but the color is not good, so I need to modify the thing. This.
It says sustain signature. But our purpose is not the word.
I think I can